Lesson 3-5, Solving Inequalities with Variables on Both Sides. Example number 1. Copy this to your notebook paper. We're going to solve the inequality and graph the solutions. We have 3x is greater than 8x plus 10. We have variables on both sides, so we're going to need to move them to the same side. I generally like to move my variables to the left. Therefore, I'm going to subtract 8x on both sides. 3 take away 8 is negative 5x. Bring down our greater than 10. Now we'll have to solve by undoing the multiplying negative 5. So we will divide by negative 5. Dividing negative 5 is the opposite of multiplying by negative 5. Remember the rule, when you multiply or divide by a negative, you flip the direction of the inequality symbol. So our solution is x is less than negative 2. Write your answer in set notation as you have learned to do so in the previous lessons. So we have the set of all x's such that x is less than negative 2. Now graph your solution on a number line. Put the negative 2 in the center and do two numbers less than and two numbers greater than the negative 2. We'll make an open circle on negative 2. We just want to show less than negative 2, so it should not be equal or include negative 2. We will shade towards the less than side. Be sure that you neatly shade your number line as well as your arrow. Finally, we will check our solution. We want to check a number from the shaded region in our original problem. Here I'm going to check with negative 3. You could use any number from the shaded region. However, it's best to choose the very next number after your dot number. Work it out to see that negative 9 is greater than negative 14. So this does check out. Example number 2. Copy this to your notebook paper. We have y plus 18 is less than or equal to 10y minus 9. With variables on both sides, you'll need to move them to the same side. Again, I like to move my variables to the left, so that would mean subtracting 10y. Make sure you subtract your variable from the like term, the 1y. So 1y take away 10y is negative 9y. You'll bring down the rest of the problem. And now we'll need to solve by undoing the operations. First, subtract 18. And then divide by a negative 9. Because you are dividing by a negative, you flip the direction of the inequality symbol. So y is greater than or equal to 3. And negative 27 divided by negative 9 gives us positive 3. Write your answer in set notation. It's the set of all y's such that y is greater than or equal to 3. Graph your solution on a number line. Put positive 3 in the center, 2 less than and 2 greater than that number. It's a closed circle on 3. We want to show that it is equal to, so include the number by making a solid closed circle. Remember the saying, extra mark, make it dark. We have that equals to extra mark, so we make a dark circle. Next, we'll shade towards the greater than side. Now check a number from that shaded region in your original problem. We're going to use 4 for our check. Work it out to see that we get 22 is less than or equal to 31. And that is true, so it does check out. Example number 3. Copy this to your notebook paper. First, we're going to take and subtract 2.7n from both sides. 6.7 take away 2.7 is 4, or 4.0. So we have 4n minus 4.1 is greater than negative 1.3. Next, add 4.1 to both sides. So we have 4n is greater than 2.8. Finally, you'll need to divide by 4 in order to solve. So our solution is n is greater than 0.7. Write your solution in set notation. We will then graph and check. All your problems you should solve, set, graph, and check. When you graph, of course, the 0.7 goes in the center. As long as you have two numbers less than and two numbers greater than that value, however you would like to count is fine by me. Here in this case, I'm counting by tenths. If you want to count by halves or whole units, as long as your counting is consistent, however you would like to do so is fine. We have an open circle on 0.7 and shade towards the greater than side. Again, always remember, whichever way the arrow is pointing in your set notation is the way you can shade on your number line. This is only true with the variable on the left. We will now check the solution in our original problem. Using 0.8 from that shaded region, work it out to see that this should check out. So we find that 1.26 is greater than 0.86. So our solution and graph that represents the solution is correct. If ever your check is incorrect, go back and check your graph or your work for solving to see if you can find your mistake. Example number 4. Copy this to your notebook paper. We have 4 times the sum 9 plus k and 2 times the sum of k plus 5. We'll first need to start with the distributive property. A number outside of a parentheses with a plus or minus sign means to distribute. So 4 times 9 and 4 times k. You'll also distribute 2 times k and 2 times 5. Now, with variables on both sides, you'll need to move them to the same side. I generally like to move my variables to the left, so subtract 2k to move the variable to the left. So if 36 plus 2k is less than 10. We'll need to undo the 36. It is positive, so you'll need to subtract from both sides 36. Now we have 2k is less than negative 26. They multiplied 2, so we'll need to divide by 2. Multiplication and division are opposite operations, so it will cancel and leave k by itself. Take a look and see. Do you think we should flip the direction of our inequality symbol? Just because we see a negative, we do not flip the direction of the inequality symbol. K is less than negative 13. It's only when you multiply or divide by a negative you flip the direction of the inequality. Write your answer in set notation, graph, and check. Be especially careful when making your negative number lines. Here you see the less than numbers on the left and the greater than numbers on the right. I have seen in the past students making their number lines backwards when working with negatives. Be especially careful when working with negatives. We have an open circle on negative 13, and we shade towards the less than side. We will check our solutions from the shaded region. By checking, you could catch so many mistakes if you check carefully. We could check to make sure we were not supposed to flip the direction of the inequality sign because we divided by a positive. And also by checking, you can see that you've made your number line correct. The less than numbers on the left, greater numbers on the right. So check with negative 14 from that shaded region. Here we will not need to use the distributive property. We can add what's in the grouping symbols 9 and negative 14, as well as negative 14 and 5. The distributive property is only when there's a variable in the parentheses. Continue to follow order of operations, and you see that negative 20 is less than negative 18. So this does check out. Example number 5. Pause the video at this time and work this one on your own. Let's check your answers. First, you should have distributed a negative 2. If you want to add the opposite, you are welcome to do so. Distributing a negative 2, you get negative 10 plus 2w is less than or equal to 4w plus 4. Notice we did not flip the direction of the inequality symbol. We are multiplying by a negative 2. However, you're not doing that to both sides. Here we're now ready to move our variables to the same side. Subtract 4w. So we have negative 10 plus a negative 2w, or just minus 2w, is less than or equal to 4. We'll need to solve by adding 10 to both sides. We have negative 2w is less than or equal to 14. Here we divide by negative 2, and that does mean we need to flip the direction of the inequality symbol. So our solution is w is greater than or equal to negative 7. Check to make sure you correctly wrote your set notation. The set of all w's such that w is greater than or equal to negative 7, and we're in graph and check. It should be a closed circle on negative 7 and shaded towards the greater than side. Finally, for your check, substitute in a number from the shaded region. Work out your check to see that negative 22 is less than or equal to negative 20. So this is a true check. Our solution in set notation is correct. Example number 6. We will work this one together in class. This concludes our lesson for 3-5, solving inequalities with variables on both sides.